So our prompt is, you work for NASA and you're developing an O-ring used in space travel. Then the sealing capacity of the O-rings is dependent on the temperature of the O-rings at launch time. The O-rings will not exceed a temperature of 55 degrees Fahrenheit. So the expected environmental temperature at launch is 60 degrees Fahrenheit. So we can do temperature initial equals 60 degrees Fahrenheit. And we can do,
Speak up a little bit.
we can do temperature, I guess minimum
Yeah.
would be 55 degrees Fahrenheit.
Mhm. How do you even draw a rocket?
I don't know. Has fins in the back. Has
It goes like this,
booster.
doesn't it?
Oh, the little point
Like a
at the
hat?
top. Yeah.
Okay, there's our rocket.
Nice. Okay.
Where should we should draw an O-ring on it though too?
Where do they go? I don't
Everywhere. Just draw like one around the center. Or in the
Just-
back, I guess. I don't know.
Back here?
Say like it's the control for the booster. Put O-ring there.
Oh, down here?
Yeah, somewhere there.
Okay, we'll just.
It works.
We can just, these are our O-rings. And, well,
On top of the diagram. Just kind of write out. Cause I'm just kind of. I don't know if I'm in it or not though.
Should we state our assumption?
right, so after initially reading it, we're only 5 degrees above what we need.
The minimum.
So I would say no.
Based off no knowledge,
Based
I
off
wouldn't
nothing.
recommend it.
I
yeah.
would not recommend it prior to research.
Yeah. Okay, so I'm gonna map out like different altitudes and temperatures, and it's basically going to what? Do
It's-
temperature change?
Yeah,
Or-
temperature,
it's going to
temperature
represent
change based off
temperature
of the altitude.
So, okay, I need you to explain this to me just a little more.
So like,
So are the lines on here,
these are.
this is ground level and then this is the different one.
Yeah. And so
Okay.
like, yeah, so like the
Okay,
starting
so
one
I'll
will
go-
be the troposphere.
I'll go even here from ground level, this is the change in temperature. And then I'll go a little like that. And then, oh, this is not a great line, but that's okay. It goes almost back to the original, and then
Mhm.
goes up a little bit, and then back a little bit, a little farther. Like that.
Mhm.
Cool.
And like label your.
Yeah, maybe label
Yeah,
what.
I'm working on that.
Just-
I'm
just
trying-
the line.
I'm
Just
just,
the
I'm just trying to figure out what all of this means.
Right.
Like you have troposphere, mesosphere. And
And also be smaller numbers.
okay, and so
And
this.
so this is our
This is
altitude, and this is our temperature.
In Kelvin.
and this is
So-
colder.
Color, yeah.
Okay, so.
Yeah.
And our altitude, I guess, is going to start at 0,
Ground level, yeah.
or I can use ground level.
And then for maximum height, is about 100 kilometers up.
Up here.
Yeah.
Okay.
And then, is there like a representation of temperature on there as well that I can write here, or?
It's in, maximum is 300 Kelvin for the temperature axis.
Which is what, gonna be like,
It
is
would
that
be- it
here,
would
or is
be-
that past the line even?
It's a little bit past the point, right there.
So here,
Yeah.
And maybe
Yeah.
put temperature and altitude, just, yeah. Perfect.
is there a minimum on there as well? Or is zero?
It's
just literally
0.
Just looks like it.
So based off this graph alone, we could say that it's a bad idea.
Yeah, so to estimate what our launch temperature, it's gonna be about 288 at launch degrees Kelvin, which
So you
is,
said, oh,
So
okay.
temperature at launch,
Yeah.
either over there or over here, is 288
Yeah.
Kelvin.
which would pretty much put it right there where that initial mark is.
Okay.
And then
Which is what on our, I guess it doesn't really matter for altitude, right? I mean, it's increasing,
It's
so,
at 0, because I think the problem assumes we're at,
ground,
yeah.
yeah.
And then if we go 55, it's 285 degrees Kelvin, which isn't much further along that line.
Yeah,
So if we're at 55 altitude, it's
from the graph, you
285.
pretty much, as soon as you're even like
in the air.
there, it's gonna be too cold.
It's in the
Right.
negatives
Way
there.
too cold, yeah.
So,
So. I
Maybe a
can-
dotted line down through the, yeah.
I can give you a
Too
rough of
cold.
what that's supposed to be.
Right.
That right there is about, that's about like -9 degrees right there.
Right here?
Yeah, -9 Fahrenheit.
Yeah, they're way gone.
Yeah.
Yeah, they're probably gone at about
Yeah,
there.
they're gonna be gone.
Maybe somewhere in there.
Mm-hmm.
So yeah, we should not launch
Don't launch.
that.
We should not launch the rocket. Or we could just wait till it's warmer. Actually,
Which-
no, that won't matter because
It
it'll
will
still
still
get
get too
colder.
The
cold.
question
yeah.
is, do they
Okay.
fail immediately, or do they kind of give time to fail? Because
Even if they
Well,
took
I guess this is a
time,
little bit of a wrong.
they still have this to cool down. And then it doesn't start heating back up until.
Yeah.
So like, I don't know how long
too
this
risky.
I'm
is,
actually gonna, here, I'm gonna write something
but,
here real quick.
sorry,
That's really ground level, so.
yeah.
draw
like-
a tree right there.
Perfect. Like, I would assume that from ground to here takes a while, and from
Yeah.
here to here takes a while, so like,
Mm-hmm.
and that's a way big temperature difference with the 55 is the minimum, and we're at -9 here. Like, even if it does take a while, I think with that great of a temperature difference and like decrease, they would get out faster anyway, right?
They would not make it.
It would not make it. Okay, so the next part is our description of potential economic costs associated with our decision.
Don't do it.
Costs a lot of money, but we should start by actually researching how
How
much
much
money
it
it costs to
Build a rocket?
build a rocket versus the O-rings.
See how much the
Right. I would assume that
A lot more, yeah.
it would cost a lot more to rebuild another rocket than it would be to just replace the O-rings with better ones.
the
But I don't know.
space shuttle cost $450 million.
$450 million.
Yeah,
Okay.
per launch.
Per launch.
The whole project itself cost $211 billion.
111 billion.
for the whole
What
project.
about O-rings by itself?
Definitely cheaper than that.
Cheaper than that, yeah. But like per launch, it's $450 for the space shuttle.
So if we launch this and it fails, not only do we have to pay to build a whole new rocket with all new resources and to launch it, which costs more money, we also probably will have to pay some fees.
Lawyers.
Explosion fees.
Like,
Maybe like
We're probably
have to
getting
build up the
sued.
whole
The
facility.
launch pad could get damaged. Could
yeah,
build
the
it again.
new launch pad.
Yeah.
Yeah.
Bad.
So economically, it's also a bad idea to launch the rocket with these O-rings.
Yeah. Let's see. What was the other thing?
Unethical.
Christian.
The constraints, requirements, assumptions.
Well, obviously our assumption is that it's gonna explode,
Yeah.
Right.
so we shouldn't launch it. I mean, even here on the graph, we can see it gets way too cold to launch it. And right there is like only a third of the way they'd have to go, and they've already blown up there.
Probably down here.
Probably down here, yeah.
Yeah.
So I guess the assumption is it will blow up.
Yeah. Then we gotta think about like the Christian
Christian
worldview. Well, if there's people on this rocket, they're gonna die.
Right.
So like,
Which is against all of everything in
Yeah.
almost every
we want to make sure we preserve their lives
Right.
and send them up in the safest way possible. So,
Yeah, and launching this rocket would not be that, so.
no. Rather spend more money over sending someone up cheap and they risk dying.
Right. That would be very unethical.
And